Our clinic this evening is going to be presented by Gerry Cornwell, who is one of our key operators in putting Off the Beaten Track together. Many of you know Gerry from many presentations that he's made and have met him at conventions and so on. He comes to us with a great pedigree in dealing with the things that make our hobby very much a lot of fun, from association with Mount Albert and now Fast Tracks and all that Al Collins is doing.
So good evening. So this was put together rather last minute. I had already done a little bit of work on this prior to this emergency replacement, but it was too bad about Kevin being ill. If you don't know Kevin Hunter from Barrett Hill Designs, he's the inventor of touch toggles, and we will have a presentation from him on control panels sometime in the future. Tonight we're going to talk about 3D print production process, what we went through in producing a model. And the reason I'm doing this is I'm no expert at this. This is something which is a new experience for us at Fast Tracks, Tim Morris and myself, and our friend Brad Mackerick, who had a lot to do with the process as well in terms of getting the drawings done. So since it was a learning process and I learned a lot, I thought it might be interesting for people to see what we did and how we did it. So the overview is, first of all, you need a concept. What are we actually making? What's the object? What's our end product going to look like? What do we want? There's a data collection process where we do research and measurements. There's a drawings process. And then there's a test of concept where we do test prints and trial builds. And then we do the fine tuning. And finally, we go into production. So we start off with a concept. And our concept was to make a really interesting and unusual portable boiler. The backstory here is that Tim Morris, the owner of Fast Tracks, his maternal grandfather's name was Bill Kelsey, and Bill owned a company in Delhi, Ontario, which made small specialty portable boilers. I believe the story started off with a local farmer approached him and asked him to build one, and he built one. Then, of course, the guy next door to him had to have one too. And the next thing you know, they had a business that went on for years, and they shipped these things all over the world. As you can see from the photo, this is a photo of the real thing. They're 8 feet long, a 2-foot diameter boiler, and they are on what looks like automotive wheels. That's what they are. And they were designed to be, they had a yoke, and you could pull them with a horse, or you could pull them with a tractor or whatever. They weren't self-motivated. And these were used largely in agriculture. That's what they originally designed for, but then they were found all kinds of use in small industrial uses, for example, and people in need of a stationary boiler or a portable boiler. So this just summarizes that information. They made both 2-wheel and 4-wheel versions, and there's one remaining that we know of, and that's in Delhi, Ontario, in a history park. And here it is. And this picture was taken by Tim. That's me in the background, and this is the lovely day we chose to go and take dimensions of the real thing. It was a little bit, we were a little bit hampered by the snow and the fact that neither of us had appropriate footwear, but kind of one of those late spring snowstorms that comes along. And you can see the yardstick leaning up. You can see my cursor here. You can see the yardstick leaning up against the back here. And this is a bag here that's got a bunch of measuring tools and various other things in it hanging on the back head. But as you can see, it's kind of a funky looking thing. It looks like almost exactly what it was, which is a homemade boiler, and quite eye-catching. So during the data collection process here, since we had the real thing to go from, we really didn't have good drawings. So we had some pencil sketches that Bill had made over the years. We have an album of that information, but we really didn't have anything with accurate measurements on it. So we went to quite a lot of work to wet and cold work to get all of the data off the prototype model or prototype device. And you can see that some of the details. There was a steam gauge here, pressure gauge. There's also a hook here the stack was hinged so that the stack could be folded down if you wanted to push the thing inside of a barn or something like that, or a garage. So that that's what the hook was here for. And there's various takeoffs where you can use it to power other devices. So that there's a couple. There's a takeoff here and a takeoff here, and there's another one on the side here. And all of these have valves on them. And it's also designed with there's enough vacuum that it'll pull its own water in. So that's done with a pipe on the back head here. So quite an interesting, fun process of getting that all handled. So from that data that we collected, I did a set of 2D drawings. I'm a pretty dab hand at doing 2D CAD drawings. Having spent most of my life as a lighting designer, light has this really annoying habit where it only travels in straight lines. So lighting designers tend to be really good at 2D CAD, but not very good at 3D CAD. So nowadays, there's a lot of software programs designed specifically for lighting designers, which do 3D very, very efficiently. But I'm old school, so I'm more of a 2D guy. But one of the things you wanted to do was get the sizing of everything down in the 2D drawings, and then the 3D would be developed from that. What I did with the valves, this was going to be a challenge because they're, of course, scaled down, they're going to be very small. And what I did was I drew it full size. So then we took that down and scaled it down to fit different size piping. The different size piping on the machine, on the boiler, varied from 1/2 inch up to 1 inch pipe, and the globe valves were sized accordingly. So we drew all 3 sizes of those. We did a cross section of the axle, and then we did various cross sections through the boiler at various parts, showing the tube detail on the inside, the flues, and the star detail on the door, and various other bits and pieces of the hardware, stay bolts through the top of the ash pan here and on the back here. So all that stuff had to be drawn, and we did all that in 2D. And then we passed the drawings over to my friend Brad Makarick. And those of you who are at Tacoma would have met Brad at our table. And Brad then turned those drawings into 3D drawings. So a lot more detail. And the nice thing with this, of course, is that you can now get renderings from the software, and it'll give you a much better idea of what it's going to look like. In order to make a 3D print, you have to have a 3D drawing, obviously. So that was the first stage of the 3D drawings, and then we could do renderings from that. And these are shaded renderings, which enable you to get a much better feel for what the model is going to actually look like when it's done. You can also apply color if you want in this stage. We didn't really need to do that. We knew what color it was going to be, so it wasn't a big issue for us. We were going to stick with a green and black theme that was used on the real thing. In this particular image, Brad has colored the valves handles to make them stand out. And you can see he also modeled at that time we were talking about having the smoke box door open and having the flues inside modeled. We ended up not doing that, but he did show the door open in this image. Here's the 3D drawing of the smoke box door. And as you can see, it's got the legend of the company, Kelsey Manufacturing Company in Delhi, Ontario, in the casting. These are cast, and we actually have one of these. So this made this part of the process a lot easier. It's on the floor in Tim's office. It's a hell of a thing to stub your toe on, I'll tell you. The other thing we were talking about at this stage of the model is we were going to do it as a kit. So we would 3D print the components, and it would be assembled as a kit. And this shows a drawing of or rendering from the 3D file, showing the boiler, and the back head is a separate part. And as you can see, none of the plumbing is on the back head. The plumbing was also going to be done as a separate part. I'll show you an image of that later. Mike has asked a question. I might as well jump into it while we're here. And he wanted to know what software was used for the 3D work. I believe Brad uses a program called Inventor. So we had originally meant to do the kit, the boiler as a kit with 14 or 15 parts, and the small parts would be 3D printed, but the boiler body would be cast in rosin, because at that point, and this was over 2 years ago, 3 years ago, getting a large 3D print was quite difficult. The technology has changed remarkably in the last couple of years, as anybody who would know who's investigated this. We looked at originally at doing the boiler body in rosin and then all the details 3D printed. So we ran some test prints, mostly with Shapeways. It was not entirely a painless experience, and they were quite expensive. So here's a not very good photograph showing the components of the kit. So as you can see, we've got the boiler, which is a fairly large piece. This is 3D printed. We did this as an experiment to see if it would work with Shapeways. Here's the smoke box, stack, a steam dome. Can't remember what that piece is. This model, of course, doesn't have a sand dome. Smoke box door, front axle, wheels, and the axle retainers or supports which go in here. These are for the rear axle. And then our plan was to use a piece of wire, a phosphor bronze wire for the actual axle. I'll get back to that question later. And here's the back head, and also here's the piping detail that goes on at the end of the boiler there, just by the back head. So this was one stage of the process. We built a couple of these, but we were having some difficulties. One of the things we also tried was doing parts in metal. So Fastrax has 2 3D printers, and the first one that Tim bought was actually a wax 3D printer, and it's designed for making masters for casting, because as you may know, Fastrax now has a line of diamond crossings, and those are all cast components. So that meant we had to invest in a wax printer. So these blue pieces here are actually wax pieces. They're extremely fragile, but they're very accurate. And of course, it's lost wax, so of course they get destroyed in the process of doing the casting. But they turned out very nicely, and these are some parts that we did with that done in white bronze. And here's the brass cast, or the bright bronze piece that we did for the smoke box door compared to a Canadian dime. And if you were wondering, the Canadian dime is the same size as the American dime. So you get an idea of the size of that. It's a little bit less than a 1/2 inch in diameter. As you can see, the words which were on the original turned out quite well. One of the things you discover is that if you do it exactly scale, these words would hardly show at all. On the real thing, which remember is 2 feet, the words only stick out maybe a 1/4 of an inch or less. If you do that in O scale, they're almost invisible. So you actually have to cheat. You have to pull those letters out and accentuate the depth of the letters to make them read. Otherwise, they wouldn't read. So here was the end product at this stage. We were very pleased with this. It looked great. It really sort of captured the charm of the prototype. There were a lot of things we liked about it. We liked the size of the valves, looked pretty good. We did have to upside the valves a little bit so they would print accurately, but they turned out reasonably well. This particular photograph there's a couple, I believe there's a couple of the white bronze. I believe this yoke here is done in metal. Yeah, we thought we were getting there, but we did have some problems with it. Now I'll show you what those were. As you can see, this is a pretty small model. So we had arrived at this completely 3D printed model, and the idea of rosin for the boiler was discarded. That was not going to be accurate enough. We were getting to the point where we had a lot more confidence with the 3D print. The idea of cast components was discarded mostly due to cost. It was going to end up being quite an expensive model if we were to do them all in cast metal components. The challenge at this point was the rosin we used was too brittle. So the rosin, the different rosins that we had tried, we tried 3, were very brittle. And when you were putting the model together, the valve handles would break off if you just touched them. They were very, very fragile. So it was really time to rethink what we were doing and how we were going about it. So we connected with an experienced 3D print guy at a show. So he suggested a couple of things. Do the model as a one-piece print, except for the back head and the stack. We hadn't tried that, partially because our 3D printer was not actually big enough to do that. And it wasn't really designed to or specified to do that stuff that large. And to use what he called an ABS like resin, which is I'd almost say it's rubbery. It's got a lot of resistance to it. You can actually move it a little bit and it won't break. It's not brittle at all. Resilient, I suppose, is the best word to describe it. So he ran some test prints for us, and the first ones failed, mostly due to insufficient curing times, but the last batch were really good. And what we ended up with is a kit, if you want to call it that, of 3 parts. So as you can see, the whole body and the boiler and the plumbing associated and the wheels and the steam dome and the base for the stack and the yoke and everything, front axle, is all one piece. Now, the tedious part is removing this from the supports. And it's actually not as bad as it looks. There's a lot of them, and they're needed because that's the way 3D print works. Everything that you see is all essentially one surface. So it's all has to be conjoined, if you will. So it all needs to be supported. And getting this off actually takes. After I'd done one, it took me about a half an hour to do the second one. I just used a sprue nipper, and to get I ended up getting all the small stuff off. And then I took this off on the bottom with a razor saw. I just used like a Zona saw and just sawed this off flush with the base, not close to the model, but flush with the base, and then went through and snipped off the rest of the little bit. So it was a little bit tedious, but it came out fine. And the little marks that are left on the model are very easily removed I just used a small file, and I also used like a sanding stick. And I got rid of any of the little nibbles left over from the supports. Here's the stack, and here's the back head. We had some issues with the back head on the first run, so we've changed the way that fits into the back of the boiler now, so it's a lot easier fit. So we made some changes to improve that alignment, and we resized some of the globe valve handles to get a better print. Some of the prints were not 100%, so we were on the globe valve, so we played with those. Let me go back up for a second. There's a valve right here which was not printing properly, and so we made a change to support for that. But other than that, it's worked out quite well. So this is the production model. We had these at Tacoma at the convention. They're not actually on our website yet, so you can't actually order these yet. You will be able to soon. That's not because of the boilers. It's actually because our e-commerce system, we had to change it. It was no longer being supported, so Tim's gone through a year and a half of hell trying to fix all that. But these will be added to the website fairly soon. And the painting of this was actually not as painful as it looks. What I did was I airbrushed the whole thing with green. This was done with Vallejo acrylics. I'm trying to stay away from solvent paints as much as possible. And then all of the black was done just with a small brush and with an AK, I believe it's called NATO black, which is sort of like a grimy black. It's not a dead black, it's a little bit gray to it. The picking out the letters on the front here was actually done with an artist's pencil, just a white artist's pencil, and just at an angle, and just gently over it a couple of times, and it turned out quite well. Quite happy with the way that worked. And of course, the red valve taps were just done with a paintbrush. You can model it with the stack down or with the stack up. That's why we modeled the stack as a separate piece. Makes a fantastic flat car load. So what did we learn? Well, this was definitely a learning experience. We had, the process took over 3 years, which sounds ridiculous, but part of it was our lack of experience. Part of it was COVID, and I'll explain that. you would think that with most industries, that during COVID suffered because of COVID. Restaurants, theaters, anything where you were dealing with the public, where you had people in a crowded situation, sports events, all that stuff really suffered from COVID. People working in offices. The hobby business went completely berserk because people were now stuck at home, and they had time on their hands, and they might even have a little bit of spending money because they're not going out to restaurants and they're not buying that new boat this year. So the hobby business got really, really crazy. We had two of the busiest years we ever had, 2020 and 21. It's calmed down a little bit now, but it was just nuts. So that sort of took the emphasis off these other projects we were working on, and we had no particular deadline on this project. So all of that played a part. Our goal really was to get it right rather than rush it and bring something on the market we weren't happy with. So that's part of the reason it took so long. We would have saved a ton of time if we'd started. Whoa, gee, I don't know what happened there. If we started with a more experienced 3D print person or with more experience ourselves, but that's how you learn, right? Over the last 2-3 years, 3D technology has improved dramatically. The $500 range 3D printers now are really good quality, especially good enough for model builders doing small parts. We have a much better grasp of the strengths and limitations of the technology, and now we're looking for more cool stuff to make. And I think that's all I have.
Okay, thank you, Gerry. We have a few comments and questions. One, are you going to make it possible to backdate the wheels for turn of the century appliances to this?
I saw that question. Yeah, that's a good question. And we haven't considered that yet, but I think that might be in the future. I'll have to speak to Tim and to Brad about that and see where we want to go with that. But yes, it's a possibility.
Then what brand or brands of resins did you find acceptable or functional?
I'm not going to share that yet, partially because I don't actually know. My 3D print guy who did this said he was using this and he was using that, and this all went back and forth on the phone. And we have ended up with a product that we like. So now I'm going to find out what he used, so we can. We haven't really settled yet whether we're going to print these in-house or he's going to do them for us. But yeah, it would be good to know what that material is. We will share that when we find out ourselves.
Okay, maybe I missed it, but what scale is this? Is this O scale?
We're doing this in O scale. Quite a few people at Tacoma asked us if we would do it in S or HO, and it occurred to me that, how big is a boiler? So we could probably do about a 3/4 size model of this without any problems. The valves would have to be maybe a little bit oversized for HO. I'm not sure if we're going to be able to print them much smaller reliably and get good results, but it'll take some fiddling to do that. But we could do a slightly smaller version of this, which might work for smaller scales.
All right, those were the questions that I spotted in the chat.
I see one here from Steve Hollenbach. The real brittle stuff is a clearish white plastic. I don't know the material. I'm curious about the robust stuff as well. Yes, and like I said, we will share that. We found that as well, Steve. Most of the materials that we had on hand were materials that we purchased in order to do masters for casting. So it was if you were to take a scale and say on one side of the scale is accuracy and the other side of the scale is robustness, and the really accurate stuff from our experience seems to be really, really brittle. You get a little bit less accuracy, I think, with the more robust material, but for this particular model, it wasn't an issue. And the other thing, I don't know if you can see in this photograph on your screen, you may see some very small amount of lines because, of course, the 3D prints, it lays down layers, right? So, and some of the early 3D print stuff was really awful for this because you got all these lines, right? And you might see some very slight material in here. Now, I didn't do anything to this other than paint it. The only place I did any sanding was where I had a support. I had a little nub that I needed to sand off, but the rest of this was just basically painted the way it was. So I don't think anybody found that any marks or anything that they saw that were objectionable.
Okay, thank you very much. All right, thank you, Gerry, and we look forward to whatever else you've got in the hopper.
Thanks, Russ. It'll be more stuff coming.